Hi everyone, I'm going to talk to you about order request optimization. The main goal of this session is to understand how it works behind the scenes and how to really take advantage of it. I am Marie-Sophie. I've been with ORDA since November 2017 in the product team. This is the agenda. First, we will talk about the scope and the purpose. We will have a look at how the order request optimization works. We'll talk about maximizing your experience. We'll learn that on Listboxes there is also an optimization. I'll give you some details about the order cache, and at the end we will talk about a few tips about using ORDA and Classic 4D. Let's start with the first section about the scope and the purpose. The optimization applies on client-server operations, but also on a 4D remote database exposed as a REST server. Before, performance depended on your database structure, on your network capabilities. When working with an entity selection, requests were sent to the server for each record and returned all its fields. So we thought about it, and there is now an automatic optimization, and we are going to learn how it works. The next section is about how does it work. This optimization relies on two steps. The first step is the learning phase. When you need an entity selection, 4D doesn't know what you will do with it. So 4D loads the first entity with all its attributes and analyzes which attributes you need. We call these learned attributes. And then comes the step 2, it is the optimization. 4D knows which attributes you need and sends requests for 80 entity pages only for those learned attributes. So to summarize, we have the learning phase where 4D observes and learns, and we have the optimization. Series of requests only for the learned attributes are sent to the server for 80 entity pages. Just a few technical details before going on. Those requests rely on the REST protocol, but no special REST skills are needed. I will explain all the necessary REST knowledge during the demo. So let's run the first part of the demo. My demo is already opened on a 4D server, and I am going to connect as a remote to work in client server. So the demo is starting. We are working with a simple database which has a person's data class and an address data class. And there is a many-to-one link between the person's data class and the address data class. And the primary key is the ID attribute. We can view the data. Here is the person's list with first name, last name, and so on, and with the address. We have several persons. We have 200 persons. Let's start now with the demo. On step 1, we are going to run the all member method to get all the entities of the person's data class. We can run the code, and we want to verify that the request was sent to the server. So we check the request. This list shows our request for the all member method. How to interpret this information? We have the REST prefix. It indicates the REST protocol is used. We have /persons. Persons is a data class name, so it indicates we ask for all the entities of the person's data class. And we have $top equals 1. It indicates the first entity is loaded. If we select this request number 1, this shows the response sent by the server. The first person has been fully loaded with all its attributes. Here is the first entity with all its attributes, age, last name, gender, and so on. And note, the related entity address has not been loaded, we just have its URI, Uniform Resource Identifier. And if we want to verify the learned attributes, we have no learned attributes yet. On step 2, we are going to loop through the entity selection from step 1 and build a collection with first name and last name. Let's run the code. We can check the collection we got. It's a simple collection with first name and last name. For the first iteration of the loop, since the first entity was fully loaded, this first iteration went OK. Following this first iteration, 4D has now learned that we need the attributes first name and last name. We can view the requests. These are the requests for the rest of the loop. Request 2 through 4 are a series of requests for 80 entity pages. $skip indicates the number of entities to be skipped since they have been already loaded. $top indicates the number of entities to be loaded, and $attributes indicates the entity attributes we request from the server. So in request 2, we have $skip equals 1, because remember the first entity have been already loaded with request number 1. We have $top equals 80, because we load 80 entities. And we have $attributes equals last name and first name. They are the learned attributes. So only requests for the learned attributes are sent to the server for 80 entities. And now I have selected the request number 2. This shows the response from the server. At the end, we have sent equals 80. It indicates we have received 80 entities. And 80 entities have been received from primary key 2, primary key 3 until primary key 81. And they have been received with only the learned attributes, only last name and first name. We can check request number 3. 80 entities have been received from primary key 82 to primary key 161, and they have been received with last name and first name. We can verify the learned attributes for the form.selection entity selection. They are last name and first name. So the conclusion is that once 4D has identified the learned attributes, only requests for the learned attributes are sent to the server for 80 entity pages. So this greatly improves performance. Let's go part of the demo. Because you may be wondering, what if I don't always use the same attributes in my loop? What happens? It's an excellent question, because the learned attributes can grow with your code, and we are going to see them in action. First, we run the same all member method, and as before, we will loop through the entity selection form.selection. We are always using the first name and the age attributes. But if someone's age is 80 or higher, we also need the city attribute, which comes from the related entity address. Let's have a quick return to the data. People 80 and up have primary keys that are multiples of 10. This person is 80, primary key is 10. This person is 90, primary key is 20, and so on. This person is 80, primary key is 30. So remembering this helps to understand the demo better. Let's go back to the demo. let's run the code and let's check the request. For the request number 1 here, it is the same as before. The first entity with primary key 1 is fully loaded with all its attributes. For the loop, since the first entity of the entity selection was fully loaded, this first iteration here went OK. And for D, learned, the used attribute are first name and age. That's why we have request number 2. Since first name and age have been marked as learned attribute, for D sends a request for the next 80 entities with only the learned attributes, first name and last name. And if I select request number 2, this shows the response from the server. 80 entities have been received from primary key 2 to primary key 81, and they have been received with only first name and age. Let's go back to the loop. For people 80 and up, we need the city attributes. So remember that people 80 and up have primary keys that are multiples of 10. But for these entities, the city attribute has not been received with the previous 80 entities from request number 2. Let's check again the response from the server for request number 2. For primary key 10, we don't have the city attribute. Let's go to primary key 20. We don't have the city attribute. And a last check for primary key 30. We don't have the city attribute. So in this case, 4D fully loads these entities in order to get the address URI, and then fully loads the corresponding address entity, because we need the city. So that's what's happened here. 4D loads the entity with primary key 10 to get the address URI, and then 4D loads the related entity address to get the city. So that's what happens from request number 3 to request number 18. And then comes request number 19. Here, 4D has finished working with the first 80 entities and now needs the next 80 entities. So this time, the city attribute is added to the learned attribute and is included in the following request. Here, we load 80 entities for the learned attributes, which are age, first name, and city. And we can verify the response from the server. We receive here the next 80 entities from primary key 22 to primary key 161, and we received those entities with age, first name, and city. Age, first name, and city for each entity. And we can verify the learned attributes for the form.selection entity selection. They are age, first name, and city. So the conclusion for this part is that the number of learned attributes can increase. They will be taken into account in request for the next 80 entities. So in other words, the next time 4D needs an 80 entity page. The next part is about maximizing your experience. Once you understand how request optimization works, you can use context. What exactly is a context? It is a label, a string you can associate to your learned attributes. It's like a shopping list. You can name your learned attributes. We still have the learning phase and the optimization phase, but if you use context, you can skip this learning phase for future queries, and you can indicate to 4D which attributes you need. And for this, I propose running a demo. So let's go on the next part of the demo about context. All member methods building an entity selection or an entity like a query, all, or get have been updated to receive an object as parameter. This object must contain a context property which must be a string. In this example, we run the allMember method with a context A. So we pass an object with a context property which is a string and the value is context A. And we use the first name and the city attributes. Let's run the code and let's check the requests. It is the same as before. In request number 1, the first entity is fully loaded with all its attributes, and the related entity address is also loaded because we need the city attributes. So the related entity address is loaded to have the city attribute. And a series of requests for 80 entity pages for only the learned attributes, first name and city, are sent to the server. It's the same as before, but now the learned attributes, first name and city, are associated to context A. And we can verify it. These are the context A attributes. They are first name and city. Now let's run the query member method to find people 20 and up with the same context A. Let's run the code and let's check the request. Don't be afraid, even though the syntax appears complex, the important pieces are here. $query, it indicates we run a query. $top equals 80, it indicates 80 entities are loaded. And $attributes equals first name and city. It indicates those attributes are requested from the server. And we can verify here for the immediately request 80 entity pages with only the learned attributes associated to context A. We can verify the response for the first request. We immediately receive 80 entities with only the learned attributes associated to context A, so with only first name and city for each entity. And so on with the following request. So the learning phase here is skipped, therefore the first entity is not fully loaded anymore. We run immediately optimized request. So the conclusion for this part is that 4D knows what attributes are associated to a given context and immediately run optimized requests. So using context, you can skip the learning phase and run immediately optimized requests. Let's move on to the next section about listboxes. The good news is that there is also an optimization for listboxes displaying an entity selection. The principle is that only attributes displayed in the listbox are requested from the server. If you select an entity to work with, only the rest of the needed attributes are requested to the server. Let's work on this example with the persons and the address data classes. In this listbox, we display all the persons with the form.persons entity selection, and we display first name and last name. We have the 4D server, and here 4D manages a list context with only first name and last name. And only those attributes displayed in the listbox are requested from the server. In the listbox property list, we have set the current item to form.currentPerson. So if we select a line in the listbox, the entity is loaded into form.currentPerson. And we can work with this entity on a detailed form, and here we work with attributes ID, first name, last name, and city. And here 4D manages a page context with those attributes, and those attributes, ID, first name, last name, and city, are requested from the server, and only those attributes are requested. it's important to know that the next, previous, last, and first member method works with this page context. We work on our detail form with the form.currentPerson entity. We work with the page context, and this is the 4D server. If we go on the next person or on the last person using the next and last member methods applied on form.currentPerson, then only attributes of the page context are requested from the server. And if we go on the previous person or the first person, it is the same, only attributes of the page context are requested from the server. We recommend to set the current item in the property list if you need to load an entity to work with, And we'll see it in action during the demo. It's very important to preserve performance. And we don't recommend to do something like this. I'll show you during the demo why it negatively affects performance. But let's run the demo about listboxes. This listbox displays all the entities from the person's data class with the form.person's entity selection. Actions on the listbox, like displaying or scrolling, trigger requests to the server to get the necessary attributes. Let's check the request. For the first request, it's the same as before. The first entity is fully loaded with all its attributes. Why? Because the first time 4D displays the listbox, for the first line, 4D doesn't know which attributes you need. And after, we can see requests only for the attributes displayed in the listbox, so only for last name and first name for 80 entity pages. I can scroll in the listbox, and we see request only for last name and first name for 80 entities. And here, a list context is managed by 4D with attributes last name and first name. These are the attributes of the list context. Now let's check the listbox property and its object method. For now, we will have a look only at the good practice. I'll show you after the demo why this bad practice negatively affects performance. As you can see, the current item is loaded into form.currentPerson. So when we select a line on the listbox, 4D loads this current item into form.currentPerson, and it is displayed on the right in the record details section. So let's select a line and let's check what happens. Let's verify the request. The person entity is fully loaded and also the related entity address. The first entity person is fully loaded with all its attributes and also the related entity address because we need the city here. So it's loaded to get the city. And the first time they are fully loaded because 4D doesn't know which attributes you need on this record details section. And because this record details section requires more attributes, a second context is created. It is the page context, and it contains the current item's learned attributes, ID, first name, last name, and city. And we can verify this page context here. These are the attributes of the page context. And now, this page context is linked to the form.currentPerson entity. And using the next or the previous member method on this current item, sends requests to the server only for those attributes of the page context. Let's click on the previous button. We can see a request only for the attributes of the page context, and the entity is received with those attributes. Let's click on the next button. We can also see a request only for the attributes of the page context and the entity is received with those attributes. If we go back scrolling in the list box, let's check what happens. So I scroll in the list box. We can verify, request, revert to using just the list context, so just last name and first name. Only first name and last name are now requested for 80 entity pages. And if we switch again, if I select again an entity, then we can see a request only for the attributes of the page context. Now, in case you are curious, I'm going to show you something. Let's go back to this. In case you are curious why this way is not recommended, it's because it negatively affects performance. When the Shift key is pressed, instead of loading the current item, an entity from the form.person's entity selection is used instead. Here we have the attributes of the list context, last name and first name. And now I'm going to select a line and I press the Shift key at the same time, and let's check what happens. This way, the list context is overridden by the page context. Why? Because we have loaded an entity from the form.person's entity selection, which is linked to the list context. So all that we do with the page context is now recorded under the list context. And if I scroll in the list box, we can verify what happens. The requests are now for all the attributes of the page context, ID, last name, first name, and city, instead of just for first name and last name as before. The optimization has been lost. So the conclusion for this part is that with list boxes, 4D automatically manages a list context for the list box if we are scrolling or displaying, and a page context if we are loading an entity and need more attributes. And don't forget to use the current item in the list box properties to switch to entities details and keep the list context clean. Let's take a little break to think. As we have seen during the demos, the ORDA requests are automatically optimized, so you can stop worrying about optimization while you are coding, and don't forget to use context if you want to boost performance. The next section is about the ORDA cache. The data you request from the server is loaded in the ORDA cache. This cache is partitioned by data class and then by entities. It expires after 30 seconds, but it is important to know that data remains in the cache for the unloads the expired data when space is needed. And now I propose running a demo with the ORDA cache. So as I said before, the ORDA cache expires after 30 seconds, but for this demo, the timeout has been set to 120 seconds to let me time to explain things. We are going to work with two contexts, context 1 in red and context 2 in blue. We will run a query with context 1 to get the form.list1 entity selection, and we will display it on this list box. And on the right, we will run a query with context 2 to get the form.list2 entity selection, and we will display it in this list box. I will show you the ORDA cache. Let's have a look before running the demo. This grid will show the primary keys of entities in the cache. When the cursor will be over an ID, the entity attributes will be shown below. If entity contains only attributes related to context 1, it will be displayed in red. If entity contains only attributes related to context 2, it will be displayed in blue, and when attributes overlap, the entity will be displayed in purple. So let's run the first query. The first entity has the primary key 2, and let's have a look at the cache. The first entity with primary key 2 is fully loaded. It is displayed in purple, and we can see its attributes below. And the rest of the entities only have the learned attributes of context 1, ID, gender, and first name, so they are shown in red. And we can verify for red entities, we only have in the cache ID, first name, and gender. Let's run the query number 2. The first entity has the primary key 3, and we can check the first entity with primary key 3 is fully loaded. It is displayed in purple, and you can see its attributes below. The rest of the entities only have the learned attributes of context 2, ID, children, and last name, so they are displayed in blue. And we can verify for blue entities, we only have in the cache ID, last name, and children. Query 1 and query 2 both retrieve common entities. For example, entity 6 here and entity 12. And we can check those entities 6 and 12 are displayed in purple, and we can verify their attributes below. They contain attributes related to context 1 and 2. Now let's wait for the cache to expire. It will expire after 120 seconds. Entities displayed in gray are expired, their data is expired, and even though it is expired, the cache is not cleared. The data remains there. We can verify it. For gray entities, we can see the data is still in the cache. 4D clears the data from the cache only when space is needed. And we can wait also for blue entities to be expired. They are now expired. In case you are curious about the ORDA cache, this slide is for you. This is the ORDA cache for the person's data class, and let's analyze this size from top to bottom, step by step. At the beginning, the stamp of the entity with ID 1 on the server is 1. The stamp is 1. The client number 1 requests last name for entity with ID 1, and this attribute is loaded in the ORDA cache. So we have last name Smith in the ORDA cache for this entity. The second time, the same client requests children for the same entity, and the attribute is loaded in the ORDA cache. We have last name and children in the ORDA cache. Then another client, client number 2, updates the last name for the same entity, and this causes the stamp of the entity to change. It is now 2. And client number 1 now requests first name. And because the stamp of the entity has changed, the attributes already present in the cache, last name and children, are removed from the cache. Because, and this is the conclusion for this slide, attributes in the ORDA cache remain consistent with the stamp at a given time. For an entity in the cache, you will never have attributes corresponding to distinct stamps. And the next section is about a few things to remember about ORDA and Classic 4D. It is important to know that when you update records with Classic 4D, the ORDA cache is unaware of this update, but we have the ORDA reload member method to reload an entity from the database. I propose running the last demo. In these examples, the ORDA cache expires after 180 seconds to let me time to explain things and to run properly the demo. These examples demonstrate the difference between classic 4D language and ORDA when working on the same record. Here we get the entity persons, the first entity person with primary key 1 with the get member method, and we get the same record with classic 4D, and we also get the related address. So let's run the code. On classic 4D, the record from the persons table with primary key 1 is loaded, and also the related record from the address table. And on ORDA, we can verify the entities are loaded, and we can also verify the requests sent to the server. Entity from the person's data class with ID 1 is requested from the server, and this is the response from the server. We have all the attributes, and note the request does not send the related entities content for the address, but since we display on the form the zip code and the city from the address entity, another request is triggered here to get the address entity, and this is the response from the server. The person entity is in the cache with its attributes, and the address entity is in the cache with its attributes. Now, on classic 4D, we are going to update the person record and the address record. We are going to change the last name and to change the city. So let's run the code. The update has been done, and notice that nothing happens on the ORDA side. Why? Because don't forget, the ORDA cache is not aware of the updates done with classic 4D. We can verify it. The ORDA cache here has not been updated. We still have the old last name value, and we still have the old city value. No request was sent to the server. The ORDA entities have not been reloaded in memory. Now let's reload the person entity with the reload member method. This reload action triggers a request here, and this is the response from the server. The server has sent the content from the person's entity with the new last name value, but not the related entity address content. In the cache, we have the new person's last name. We can verify it for the person entity in the cache. And for the address entity, we still have the old value for the city, because the related entity address has not been sent by the server. And the new last name value is displayed on the form. Now let's reload the address entity with the reload member method. This triggers a request, and the server has now sent the content for the new address entity with the new city value, and we can verify the new city value is now in the cache. And it is displayed on the form. Now, in case you are curious, we are going to run exactly the same demo, but we will wait for the cache to be expired before reloading the person entity. So we get the person record, we make the update, the person entity is in the cache, the address entity is in the cache, and we are going to wait for the cache to be expired, so we have to wait a few seconds. The data in the cache is now expired, the entities are displayed in gray, and now let's reload the person entity. The reload action triggers a request, this first request. The server has sent the content for the person entity with the new last name value, but since the cache was expired, a second request has been sent to the server to get the address entity because we need the zip code and the city on the form. So we have a second request here, which is triggered, and we receive the new city value, and it is displayed on the form. This concludes the presentation about ORDA request optimization. This demo has been specifically created to show and explain in details how ORDA request optimization works. And to do this, special tools were developed in an internal debug version of 4D. Thank you for listening and watching. It was a pleasure to make this demo.